Welcome back. We're going to look at the next three examples for applying some systems of linear equations here. All right, we have this. A library contains 2,000 books. There are 3 times as many nonfiction books as fiction books. Now we see that there are two types. Write and solve a system of equations to determine the number of nonfiction and fiction books. So we're going to write and solve. So right now, first thinking about what things we don't know is we don't know the number of nonfiction or the number of fiction books. So that means those books are what will be our variables because they're the things we're trying to find out. So I'll make X the first one of these that showed up in the problem, and that's nonfiction books. Books here, okay. And Y is fiction books. Books. So what do we know? Well, we know there's 2,000 total, so this many and this many makes 2,000. Well, that gives us a nice equation, and I'll write it over here. X plus Y is equal to 2,000. And there we have our first equation. Now, there are 3 times as many nonfiction as fiction books. So I'm going to do the method. Not the only method, it's just one that I'm comfortable with, so I get to show it off. So X is the non-fiction and Y are the fiction books. There are 3 times as many non-fiction books as fiction. So that means there's more non-fiction. So let's say for Y there was 100 of these. Well, there are 3 times as many non-fiction, so I'd multiply it by 3 to get 300 here. Or if I had 500, I'd multiply by 3 and I'd get 1,500. Or if I had, let's say 1,000, I'd multiply by 3 and I'd get 3,000. So whatever number I get here, if I multiply by 3, that will give me the X. Or I'll write this as 3y and X, so X is equal to 3y. Okay, so I'm going to write that up here as X equals 3y, and I have my second equation. And it sounds like this X and this X, since they're the same, I could just substitute 3y in here. So I'll write out the main equation first, and then I'll substitute 3y for the X. So, whoops, I put an X here and I meant to put a Y. Now you can see a 3y. 3y plus y is 2,000. Put these two like terms together. 3y plus 1y is 4y. It's 2,000. And when we divide by 4, hold on, let me get this back to where it should be. Okay, so when we divide over here by 4, we get y, and 4 goes into 2,500 terms. Ooh, so I actually had it over here, that if there's 500 of those, then with x equals 3y, x equals 3, 500, and that's 1,500. So that means non-fiction books, okay, there are 1,500, and fiction books, there are 500. And there are answers. So we had 2 equations, one of them very simple, but so what? It's still an equation and it's right. And then 1,500 of the nonfiction books and 500 of the fiction books. Okay, let's take a look at the next problem. This one is actually what you would call a break-even point, or break-even question, because it has a break-even point in it. Break-even means that you're breaking even. You're having 2 sides being equal, or 2 things being equal. Well, let's see here what we have, what this is all about, or what we could sort of like do with it. The chess club, 16 members, and it gains a new member every month. Okay, so chess has 16 and it gains 1 new member every month. Film club has 4 members and gains 4 each month. Okay, so new is 1 and 4. New. So write and solve a system. So again, it's write equations and then solve the equations to find when the number of members in both clubs will be equal. So I'm going to do two parts, have two things going on at once. So in chess, we have 16 members, M-E-M, I guess I'll write out members, plus 1 monthly. And the film club has 4 members plus 4 new ones monthly. Okay, let's say we're going to do it. We're going to think about this by setting up, again, a table of values for it. So I'm going to do X. Well, actually, X isn't best as the month. Okay, and I could solve equations by starting right off with making them, but I think I'm going to make my equations, well, I guess I will do it with months. I want to make my equations sort of as I go along here. So let's say that this is X, and that's the number of months. And Y is the number of members. Y is the number of members. Okay, I don't like how I wrote that one, so in fact I think I'll rewrite this whole part there. So that part, that's X, and this is months. Y for members. Okay, that's looking better. Well, here, let's start right off when there's no months that have passed. That means it starts off with 16. When there's 1 month that's gone by, we're adding 1 to it, so it's 17. Okay? And then when we get to 2 months, okay, well, but how we get that 17? We did a 16 plus 1, but then, hey, we'll add 1 more, we'll make the 18 here. At 3 months, the 18, oops, let's get up here, the 18 becomes 19. Well, what if it's X months? What we did here is we did 16 plus 1. And here we did 16 plus 2, and here we did 16 plus 3, but the 1, 2, 3 didn't change, or changed, whatever. So here, I'm going to write this differently. Watch how I think about this. This 16 here is 16 plus 1 new number, but 0 months here. Okay. So 0 times 1 is 0. 16 plus 0 is 16. Well, now 17, oh, no, I don't want the 17. What I'm going to say is that we have 16 members plus 1 new member in 1 month. That becomes 1 times 1 is 16. That becomes 17. Then for the 18 here, we're not going to put 16 plus 2. We're going to do 16 at the beginning plus 2 months have gone by. Oops, wait a minute. I didn't mean for that. That first number is not the number of months. It's the number of new members and the number of months. So that's a 2. 16 plus 2 is 18. Let's do 1, 8. And that's a better 6 if I go like that. And then now we have 3 new members here, but it's the 3rd month. So it's 16 at the beginning plus 1 new member every month and 3 months. And that's 3 plus 16, so we get a 19. So in this one, we're going to need 16 plus 1 new member times X months. So whatever number is here, which is our Y, that's equal to 16 plus X, or X plus 16. So Y is equal to 16 plus X. Usually we want to put the X in front if it's positive. And I now have an equation here. So the key to this is what I did here, where I put the number of months here, which happens to be X. And so it's 16 plus 1x, but the x becomes 0, so 16 plus 0. And then for this one, the months are 1, so 16 plus 1 times 1, and then so on down the line. So it actually turns out is like 16 plus the number of months, which is why it's 1x down here for the equation. Whew! Okay, let's do it again on the other one. So the next one for film, whoops, let's get this where I can use it and you can see what I'm doing. Okay, so hopefully you can see the other side now here. So for film ones, it's 4 members plus 4 new people monthly. I'm going to do the same X, Y table, months, members, okay. And let's start off that 0 months have gone by. So when that happens, we have, and I'll just start right off doing 4 new members plus, or 4 members at the beginning, plus 0 new ones. But the reason it's 0 is because there's 4 every month and there's 0 months. So 4 plus 0 is 4. And then 1 month, that's the number of old members plus the number of new members every month, and 1 month has gone by, and 4 plus 4 is 8. And then the second one, after 2 months, we have 4 new members, or 4 old members, the usual members, plus 4 times the number of months. So that's 8 plus 4 is going to be 12 of them, equals 12. 3 months, we're going to have 4 members starting off, plus 4 every month, and there's 3 months. So that's 12 plus 4 is 16. Now let's put it in terms of with a variable. If it's x, that's 4 members starting off, plus 4 new members every month, and it's x members. So that's going to be equal to y, because all of these numbers, these are our y's. So 4 plus 4x equals y, or if we're going to put it in slope-intercept form, y equals, and then the 4x plus 4, the x will come first, and we now have another equation. So we have these 2 equations. What we need to do now is to solve them. So let's write them both over here. Y equals x plus 16. Y equals 4x plus 4. Oh, this is one of those that we could pretty easily graph, but it's even easier just to say y equals y. And since y equals y, then x plus 16 must equal 4x plus 4, or y equals y. Like that. X plus 16 equals 4x plus 4. I think I'm going to get the x's on the same side, but this side the x's are larger. So I'm going to do minus x, and that's going to be 16 equals, well, 4x take away x is 3x, so got that, and plus 4. And now let's move that 4 over to the other side. 16 minus 4 is 12, equals 3x. Let's divide by the 3. X equals 4. What did x stand for? It was the number of months. So in this case, x, and in this case, in a break even like this, this is the number of months we need. So it's 4 months. At 4 months, the number of members are equal, or in 4 months. I suppose it's at the end of the 4 months. So in the 0th, or is that the beginning? It'd be an interesting discussion to have, but our answer is going to be in 4 months, the number of members will be equal. And that's how you solve this kind. In this case, what I did, in each of them still, I wrote one of them like y here in terms of x. I wrote y here in terms of x. And because y equals one thing and y equals another thing, those 2 things are equal to each other. All right, good problem. I like this one as a way of showing how you're breaking even, the number of months. We could have, if we continued the charts here, this would have been well, we would have gotten 4 and then 20 new members. We'd have 4 and 20 here. Here, we'd have 4 and 16 plus 4 more, so we'd have 4 and 20 also. So 4 months and 20 members for both of them. And then, of course, because the film club gets 4 more every month instead of just 1, film club is going to start getting larger numbers than the chess club. All right, let's go and look at what would be our last problem of the examples here for applying systems of linear equations. So we have 2 people, Tia and Ken. They sold snack bars and magazine subscriptions for a fundraiser. Okay. Tia earned $132. Ken earned $190. So what other do we need? So define variables, formulate a system of equations, and what was the price of the snack bar? And was it reasonable? Okay, so variables. Well, we need to know how many snack bars and how many subscriptions. So I have a feeling that those are going to be our x's and our y's. So let's put x equals the price. Oh, well, wait a minute. Yeah, we already know how many here, how many here, how many here, and how many here. We need to know the price per snack bar. So I put the money sign, but I think I want to put the price, the word price instead. Okay, so x is the price of snack bars, and y would be the price of magazine subscriptions. Okay, I'll abbreviate those there. Well, this thing here tells us that Tia sold 16 and 4 of snack bars and magazine subscriptions, and Ken sold more of both, 20 snack bars and 6 magazine subscriptions. And he earned more money. It makes sense because he had sold more of these. So I think in this case, since we have snack bars and magazine subscriptions as the 2 things, it's sort of like we're going down this way. Let's make equations for each individual person. Okay, so Tia, let's say that Tia here is the number of snack bars was 16. So 16 snack bars times the price of the snack bars. 16 times x, but we don't need to show the little dot for multiplication, so I'll do 16x. So 16 snack bars times however much money, that's how much she made on snack bars. And then she had 4 magazine subscriptions, so 4y is the price of the magazine subscription, so 4 times y. And Tia earned $132. So since we're told how much she earned, we should put this in amount of those. For Ken, I'm going to write it at first in terms of the amount of money times the number of snack bars plus the amount of money, y, times the number of magazine subscriptions, 6, using these, is equal to $190. But we usually put the variables afterwards regardless of what they are. So I'm just going to rewrite it as 20x, 6y equals 190. So we have this equation, and we now have done the first part of this, which is write a system of equations. But now we're going to need to solve it. And this is one of those where substitution doesn't look good and graphing looks even worse. So let's write the 2 of them out here first. 16x plus 4y equals 132. 20x plus 6y equals 190. So if I want to make the coefficients the same on one of them, rather than the larger numbers of 16 and 20, I think I'm going to look at the 4 and 6 and their first common multiple is 12, or the lowest common multiple form is 12. So I need to multiply this one by 3 to get to a 12, and this one here by a 2 to get it to be 12. So the first one becomes 48x plus 12y equals $396, or 396. Yes, that wouldn't be dollars. If I multiplied by 3, yeah, did it 3 days worth. And the next one will be a 40x plus 12y equals 380. That enables us to get rid of the two 12s, but because I didn't use a multiplier of negative over here, we'll have to subtract the whole equations. So 48 of the price of snack bars minus 40 of them is 8 snack bars times the price. Or, yeah. And 12 minus 12, and those cancel out. And 396 take away 380 is 16. Well, when we divide by 8 on both of these, we get a simple x equals 2. So that's a good place to start right now. If x equals 2, well, that tells us something. What was the x? The price of the snack bars. We now know that that's $2 per snack bar. Oh, that's what was being asked for. So we have to think, is it even worth it to get the magazine subscriptions? It's not necessarily, but I'm going to figure it out anyway. So I'm going to put, if I put 2 back into either one of these, I'm going to get a 25. I'll just tell you that right now here. So let's put, so if y is 25, 25 per each subscription, $2 for each snack bar. That sounds reasonable. $2 when I was growing up would make it really expensive for a snack bar. But $2 these days is not that much, unfortunately. So I'd say $2 is pretty reasonable for that. So the answer will be snack bars. Whoops, let's write that more. Cost $2 each. And the answer is reasonable. Answer is reasonable because it makes sense for, because magazine subscriptions should be a good deal higher, or snack bars should cost a lot less. The answer is reasonable because, there's an abbreviation for because, snack bars should cost a lot less than magazine subscriptions. Now, you could have written this and worded it slightly differently, maybe even a lot differently, but as long as you give the same idea here as to what it means, then you would be considered correct for that. Okay, $2 each, and that it is reasonable because the prices make sense. A cheaper thing and a more expensive thing. Well, that's the last of the examples here. If you think about what each of these show in the 2 videos, I need to move this up and see it. The first one is about the pumpkin and squash, and that one and Ramiro and his overtime are pretty much the same idea. You just had to write one equation, sometimes adding, sometimes multiplying, so one of them will be based on the other thing. And then we come down to making baskets in basketball. And even a simple thing with 2-point baskets and 3-point baskets can be an X and a Y, and they add up to a certain number of baskets, and then the number of points adds up separately. Okay, and then another one, sort of simple type, like the first 2 problems are actually all 4 problems are pretty much the same. Is you make up 2 equations, and then you can solve it. And the equations, one of them tends to be a little easier than the other equation. And this one was a break-even type of question to find when both things will be true at once. And this one required using a chart And in this case, found that it was the price that was different, or the price was the thing we didn't know, not the number of things. Well, you now have seen some good examples, and hopefully it will help you with doing your own, figuring out your own, and seeing techniques to try to solve these. First, having to think really hard about what the equations are, and then after that, the solving of the equations are pretty easy for you now. Well, I hope this helped you, and appreciate you watching, and make sure you do see the first part of the video too, so you can see all 6 of the examples. Have a good night.